Hey, this is Mr. Ward, and this is the video key for exit ticket 28.1. And we're going to deal with a couple of questions here. So you've got this 100-foot tall television antenna, casts an 100 meter tall, casts an 80-meter shadow, and a nearby telephone pole casts a 16-meter shadow. And of course, what we're dealing with is a couple of triangles. So here's one triangle, and we have another one that's casting a shadow here as well. So there's, of course, there's a imaginary line here as well. So here's our 100-meter one. Here's our shadow. We've got 80 meters. That's the cable. And then over here, we've got a 16-meter shadow. So what you got to work out a little bit here is that this angle is a right angle because these are vertical things. So that's one angle you've got. And then the angle of the sun is going to be the same in both cases. So you can relate to these as similar triangles by the angle-angle theorem. Because if you have two angles, then you have all three angles. So this angle here will also be congruent. Let me make a better mark there to this one. Okay, and then what all that means is these two triangles are similar triangles because given the sun is as far as it is, even though there's a slight difference in angles, we can essentially treat them as the same angle coming from the sun. Okay, so now we've got a 16-meter shadow and 80-meter shadow, and we have, we'll call this T here. Okay, so we can just say T is to 16 as 100 meters is to 80. And we can just set up a proportion like that. Okay, and so 16 times 100 will equal T times 80, and we can just solve that thing. So here we go. So that means that 80T is going to equal 16 times 100. So that means T is going to equal 16 times 100 all over 80. Okay, and then we can start simplifying that as needed. So we can factor a 0 out of here and a 10 out of here and a 10 out of there. We can factor an 8 out of the 8 and an 8 out of the 16, and we're left with 2 times 10 all over 1, which is going to equal 20 meters. So this up here is going to be, the telephone pole is going to be 20 meters tall. Okay, cool. We got that one down. Let's take a look at 4b. Now, you're going to need this theorem. If a line is parallel to one side of a triangle and intersects to the other two sides, it divides them proportionally. Okay, so we've got this line and this line are declared to be parallel. And I'm not asking you to prove this right now, although we could. We are supposed to prove that AB is to BC as AE is to ED. And ultimately, you'd be able to prove that by dealing with the similarity of triangle ACD and triangle ABE. Since these are parallel, this angle is congruent to this angle by corresponding angles. This angle here is congruent to this angle by corresponding angles. And angle A is congruent to itself by reflexive. And you would be able to work out that these segments are proportional. But we're going to just accept the theorem right now, and we're going to deal with this set of triangles. So we got TP. This is TP. Okay, I'm going to use a different color this time. So TP here is parallel to VW. So I'll make a little parallel mark right there. And we're supposed to figure out what ST and TV and PT are. All right, so let's start looking at this. So ST is part of this one that's 10, right? Okay, but ST is one of the portions that's cut by one of these parallel lines. So ST is going to be to 9. We could say this, ST is to 9 as 10 is to 4. Okay, that's a thing we could do. We can set up that proportion. We can also say TV is to 4 as SV is to SW. That's another thing we can say. And ultimately, we can also say TP is to 8 as 9 is to 9 plus 4. So those are all proportions we can set up. So here's what I'll do. I'll start setting those up. So let's start with ST. ST is going to be, so ST is to 10. We could do this one as 9 is to 9 plus 4, which is 13. So we can solve that. So that first one will end up with ST is to 10 as 9 is to 13. Cool, we can do that. So then we get the products here. So this product is going to equal this product. So the products of the means will equal the products of the extremes. And that means we've got 13 times ST is going to equal 10 times 9. And then we can divide both sides by 13. So ST will equal 90 over 13. And then we can work out what 90 over 13 is. I'm going to go ahead and use a calculator. 90 over 13 is going to get us 6.92. I'll round that to 6.9-ish. 6.9. I'll make it 6.92. I'll do that. Okay. Yeah, that's where I'll round it 6.92. Okay, so ST is 6.92. Now, let's work out the next one. I'll pick a different color for that. Let's take care of TV. So TV, we can say TV is to 10, if we like. We can do it that way. So TV is to 10, as 4 is to 13. Okay, I could have used our 6.92, but since it's a rounded number, I'm actually sidestepping that. Okay, so once again, the product of the means is going to equal the product of the extremes. So we can set all of that up down here. So we know TV over 10 equals 4 over 13. And so 13 times TV is going to equal 10 times 4. And that's going to be, we can now say TV equals 40 over 13. And we can figure out what 40 over 13 is pretty quickly. So let's do that. Make that 40. And we get 3.077. Or we can just say 3.08. I think would be a reasonable rounding. Equals 3.08 rounded. Okay, and that one is also rounded. And you should round these things. And now the last one, we want PT. So PT is to 8 as 9 is to 13. So I'll pick a different color to set that up. We'll use green. So PT is going to be to 8 as 9 is to 13. Seems like 13 is playing a big role in this one. So that means that the product of the means is 8 times 9, and the product of the extremes is 13 times PT. And that's how we'll solve this. So PT over 8 equals 9 over 13. And that means that 13 times PT equals 8 times 9, and then we can sort that out as PT is going to equal 72 over 13, and we'll figure out what 72 over 13 is here. So 72 instead of 42, instead of 40, 72 over 13 is going to give us 5.54 rounded. So there we go, 5.54 rounded, and that's your answer. I hope that helped with this one.